Everybody's camera's on. Doing good with that. Good, good, good. I'll give it just a moment here, and then we're going to go ahead and jump right in because we got to make sure we cover everything we're looking to cover today. I've actually already cut back on what we were going to cover today because I said let's not get silly and cover get so much that we can't get it done. Don't get so much we can't get it done. But hey, I do want to start with. I'll remind myself of this. All right, I don't want to forget our estimation stuff. Let me pull up this other screen. And we're starting this week looking at this. So there's one sheet of paper lying there, and there's a ream of paper. So how many sheets of paper are in an entire ream? Now, some of you may know this because a ream of paper is a specified amount of paper. All reams have the same amount. One ream of paper is equal to this. But if not, give it a guess because, you know, that's a pretty big stack of paper. Keith's throwing a guess out there. All right, Parker, Joseph, thank you. Give it a guess if you don't know. All right, I've had a few guesses. I've seen 550, 300, 500, 1,000, 600. And I'll tell you, the right answer has been guessed out there. It's been out there. Some of you may not even be a guess. Some of you may actually know. But how much paper is there in a ream? How many sheets of paper in a ream of paper? So if you need to estimate it, there's one little thin, and there's a whole bunch of them right there. If you don't know what's in a ream. Well, let's take a look. Let's take a look at this one. It's right there, the arrow pointing. There are 500 sheets of paper in a ream. 500 sheets. So if you get a ream of paper, that's 500 sheets. I've already opened my ream and thrown the package away, so I can't show you. But that is, all reams are 500 sheets. So if that is 500 sheets, how much paper is in a box? So you got to kind of estimate. Oh, yeah, Keith, you had twice as many, man. You got to kind of figure out, okay, well, how many of those packages would be in a box? And we know that a ream is 500 sheets of paper. All right. Now, generally, the reams are lying down in the box, by the way. They just prop that one up to kind of show you the size. Generally, they're lying down in the box. I'm seeing many thousands. I see 1,000, 5,000, 1,500, 6,000, 2,000, 4,000, 5,000, 2,000. Give it a moment for a few more. 2,000, 3,000, 5,000. So if we look at the top of the box, you can kind of see that two of them could fit side by side. If this is a ream of paper and one of them would fit right there, one of them fit right there. So how tall is it then? How many would fit 2 by 2 comparing to this to that? All right, let's go see. There are 5,000, it says on the side of the box there. There's 5,000. There's two of them stacked on top of the box right there. So there are 10 reams in a case of paper. And that's true anyway. Go to Office Depot, go to Sam's, go wherever sells paper. And you can get a whole case of paper, a whole box. And it'll be 5,000 sheets, 10 reams in every one. All right, let's try this then. How many cheese balls are there? And we're talking about all 6 of them, not just how many's in one. We have 6 buckets of cheese balls. So if you're sitting down for your Netflix binge, you said, all right, I've got all my cheese balls here. Let the Netflixing begin. How many are you eating there? That's a good question. How many is in one? We don't know. We got to kind of estimate how many is in one, and then take that 6 of them. I don't know. Have you eaten the whole thing of cheese balls at once? Can you Google how many? Well, yeah, if you want to give up on estimating, we're trying to figure out how good we are at guessing, at estimating. I wonder if it'd tell you in Google. You can try it, but yeah. Yeah, if you've ever eaten a whole tub of cheese balls, how many did you eat? Did you count them? Now remember, now we have 6 of them, so be sure and take it times 6. However many you think is in one, you got to figure there's 6 of them there. So like Dallas says 1,200, so that'd be like 200 in each one. There's 200 in this one, and I've got 6 of them. That means I'd have 1,200. Surely somebody's answer is close. I don't remember what the answer is here, but I think you got some really good guesses. That somebody's real close. I think there's a couple people that's probably real close. 1,500. All right, we're ready to reveal it. Let's see. Let's see. So it says 4,416. So there's 32 in a serving, and there's 23 servings in each one. So if we want to look at the math, so if you've sat down and eaten one of these and you want to know how many you've eaten, let's see. If there's 32 per serving and you ate all 23 servings at one time because you were Netflix and binging there, there's 736 in one tub of cheese balls. And then if you take that times 6, that's where they get the 4,416. So there's over 4,000. And somebody guessed 4,000. Somebody guessed 4,500. Kiana guessed 4,500. So you were off by like 84. And of course, that's an estimate too, because yeah, maybe this one's got a couple extra or missing a couple. But that's a lot of cheese balls, folks. All right, one more. Well, there's 2 more. We're going to do day 14 and 15. Say, in one strip of staples, how many staples are there? They're a little bitty in there. You know, staples aren't very big. So how many are there in one? And when you refill your staple, you pull out one of those and put it in there. How many staples you got now? 200, 150. I would think that's got to be a couple hundred there. I hate to count them. Hate to be the person counting. 250 to 300. All right. Yeah, staples are real skinny, you know. So there's quite a few there. 250. I got to find my stapler. I haven't found my stapler this year. I was going to move my signs around up there. I do have my new sign to put up here this morning, but I didn't use staples. 300, 250. Well, let's see how many. Let's see how many staples are there. It says 210 per strip. So you guys are right around there. I saw a lot of guesses at 250. Man, you guys are doing super on that. So yeah, there's if everybody wants to count that and verify for us, but the box tells us there's 210. So when you reload it, a little bit more than 200, 210. So now you know what the next question is going to be. Yeah, how many come in a box then? How many's in there? Now these are kind of back to back too. They kind of fold like a next to each other. So there's not just 12 packages in there. There's more than that. There's more than 12 sleeves because they'll slide them in this way and slide them in this way and double stack them. But now we know there's 210 on each row of staples. And we got this whole box that's got a whole bunch. It's going 2520. Joseph's doing double that with 5,040. I got some good math going here. Seeing 2520 a few times. Let's see, do I have any staples here even? I know I don't have my stapler, but I was wondering if I had a box of staples. Seems like I had a small box of staples somewhere, but it has escaped me. Nope, no staples there. It's going to kind of compare them and show you there, but no staples here. I think all my staples are at home. All right, I'm seeing 25, 20, and 50, 40, and that's about it. Not many people want to get into this one. Yes, Miss Hartwell. Oh, Miss Hardwell's got a whole big thing of staples there. Yeah, look at hers. Yeah, they're piled up big time there. A little short. It doesn't look like the 210 per, but still, you can kind of see how they stack them. They'll stack them right up on top of each other. There's a big box of standard staples. And yeah, they'll fill it up. All right, let's see what the official answer is then. Here's day 15. There are 5,000. And you can see how there's some that go this way and some go that way. So they kind of make a full box because they'll set them inside each other like that. So there's like, 24 or so in there. Because 5,000, let me think right there quick. I don't think 5,000 divides by 210. 5,000 divided by 210. 23.8. There's actually over 5,000 because there's like 24 of them in there. So I think there's probably more than we think there. So if it's 210 times 24, so those 5,040 guesses, I bet you nailed it because I'm betting this is just a minimum number, just in case it might have broke a staple tour off at the end. If they say there's 5,040 and someone counts it and says that there was 5,038, they don't get sued. So they just say here's 5,000. But I'll bet you were right on it, Joseph. I bet you were there. So, all right. That was our estimation thing. I wanted to have that up there. But we're going to get into Buzz, take a look at all of this. I do want to point out we're on our regular virtual schedule this week. So today is our mandatory class. Wednesday and Friday, because Friday's an A day. The only ones that have to be in here is people whose grades below 70%. Now, I will be here. So you want to come see Mr. Brock, I will be here. But you want to know, do I have to be here Wednesday and Friday? Tomorrow you're doing your grade check. And when you do your grade check in advisory, any classes that are below 70%, you need to be here. Check RTI scheduler every day too, because your teacher put it in here if your grade's below 70%. For me, last time I looked, there's 4 people that have a 0 in this class because we had an assignment and they didn't do it. Okay, guess I'll see you 4 people Wednesday and Friday because you'll do your grade check tomorrow and say, oh, I have a 0 in Algebra 2. But most everyone did it, but there's still a few folks. It's like, Mr. Brock, I'd like to come see you as much as possible. Okay, come on down. I'll be here. So I've closed the Google form, but it's still in Buzz. So you don't have to just sit there with a 0. If you still want to turn it in late and get the points for it, it is still in Buzz. And we'll look right here. So I'm gonna pull up Buzz and let's see what we are doing this week. Because we're starting in Buzz each week. You want to have a pencil and paper. You want to have pencil and paper because you want to take notes. The way you learn math is to do math. So I'll give you a minute or so. Grab you a pencil and paper, a notebook, wherever you want to keep your notes. And I got it here on the screen. But yeah, there's that first assignment right there on the screen. AB plus C, B plus AC. All right. So yeah, pencil and paper to take notes. The best place, I try to get everyone in the habit of doing this. The first day of the week, when you get into Buzz, you should go to the grade screen. That's really the best place to go. You can go with this little icon where I have, or you can go to the menu and choose grades there. Either way, I like to use this little icon. That's just real quick. When you go to this grade screen, it'll tell you the big picture. Let's see. This is past due because that was yesterday. But, oh, look, I've turned it in and I've got a grade for it. Okay, so I'm good. What are we doing this week? Well, August 31st is this Sunday, so all I have is one assignment this week. And then I can see what's coming up. Oh, here's the next 2 weeks. Next 2 weeks, we're doing these other 2 assignments. So the grade screen gives you a nice picture of making sure you don't have anything that's past due. I don't have anything that I would, have it turned in. And I know exactly what I need to be doing now. 1.01, solving systems of equation algebraically. So let's switch back over to the activity screen because this is not where the assignments are. This just shows you the grade and what's due what. If we scroll down, here is 1.01, solving systems of equation algebraically. Here's the lesson and the assignments right underneath it. First you have the lesson, then you have the assignment. So we're going to look at this. This AB plus C, I do want to talk about that, but I'm going to hold off for next week because there are some people who haven't done it, and I still want them to get their thoughts if they want to turn it in. Like I say, I accept late work, so it's still open for those folks because you don't want to take a zero on it when it's pretty simple. There's no wrong answer. If you put some thought in it and tell me what you think, then we'll talk about it next week and see what really works and what really doesn't work. Because some things I've seen, well, I see what you're thinking, but it does not work. All right, we're going to go and look at this lesson during class today. Starting out our year with systems of equations. All right, so we got a little story to start out here. Danielle is playing the newest app on her phone, Algebra City Defense. Hey, everybody got that? Have you got Algebra City Defense on your phone? That sounds like a cool game. By golly, it's got algebra, right? Algebra City Defense. So in the game, she must help the Mathonauts defend the city against a giant three-headed monster. She can use missiles or ray guns, but she's only got room for 7 and only 23 batteries to run her missiles and ray guns. What's she going to do? How can she help the Mathonauts save the city? Algebra City Defense. Love it. So here's what we're going to learn this lesson. We're going to answer the following questions. What methods can be used to solve a system of equations? What type of solutions do the methods for solving systems of equations find? Okay. This lesson has 10 pages. So let's go to page 2. Learn. So systems of equations. The remedy for Danielle's situation is to use a system of equations. So that's a group of 2 or more equations involving the same variables. For example, x plus y equals 3 and x minus y equals 1. Same x and y, just 2 equations using x and y, and that's a system of equations. So a system of equations is 2 or more used as constraints or parameters for a situation involving the same variable. So for example, after doing more research on the game, Danielle finds that missiles use 5 batteries and ray guns use 23 batteries. And she said she's got 23 batteries she can use to defend Algebra City. So she set up this system of equations where M represents missiles, R represents ray guns. So she's got M plus R equals 7 and 5M plus 3R equals 23. Now, why would we use those equations? Why does that work? I'm going to get some paper out and start working through some of this. Okay, well, this is my new table, so the background looks a little different to me. So these are the equations she came up with, and M is missiles, and R is ray guns. Right, so that's what she's doing with the M and R, missiles and ray guns. So she comes up with this equation, M plus R equals 7. And this is because it says she can use 7 weapons. So she knows M plus R has to be 7. That means she can have 7 missiles, but then she can have 0 ray guns because that would give her too many weapons if she had any more ray guns. Or she can use 7 ray guns, or maybe 5 missiles and 2 ray guns, or 1 missile and 6 ray guns. But all she knows for sure is she can have a total of 7 weapons. So where did this equation come from? Well, if you remember what she said, missiles she discovered uses 5 batteries. And ray guns need 3 batteries. So every missile she uses, she's going to have to put 5 batteries in it. And every ray gun she uses, she has to have 3 batteries in it. And she's only got 23 batteries already. So if she had 7 missiles, she couldn't even use them all. Because every missile takes 5 batteries and she's only got 23. So that means she would have 5 missiles. Well, she'd have 4 missiles really, because the 5th one, we'd only have 3 batteries to go in the 5th one. So for 20 batteries, she could fill up 4 missiles. But the next battery is only going to have 3 batteries in the next one, so it's not going to work. If you don't have it full of batteries, it doesn't work. So if she has 7 missiles, she's only going to be able to use 4 of them, and the other 3 is sit there needing batteries. So that's really no good. So you don't want that. If she has 7 ray guns, they only need 3 each. So she can fill up all the ray guns, but then she's still got 2 batteries. So she could have done something better. So she has this equation. She's like, all right, that kind of gives me where to start. First equation comes the missiles and ray guns taking up 7 slots. The second equation is 5 batteries for missile, 3 batteries for ray gun, using the ship's 23 batteries. So notice we've got 2 variables and 2 equations. So how many equations do you think would be necessary for a system that had 3 variables? Oh, yeah. If they had 3 variables, we'd need 3 equations. So depending on how many equations you have, that's how many variables are going to be included in that. So like this one, M is in both equations, R is in both equations, but that's all we have. 2 variables, so 2 equations should be able to solve it. There are 3 standard methods of solving systems of equation: elimination, substitution, and graphing. Good. So that's our 3 choices. I'm going to write those in our notes. Elimination, substitution, graphing. So all of these will solve. It's just 3 different ways we can solve a system of equations: elimination, substitution, or graphing. So let's start off with something a little similar before we get back to this one. Little simpler. But if you're writing those down, those are right here on this page. So let's learn about how to solve using elimination. So let's solve the following systems equation using elimination. So I'm going to turn my paper over. We're going to work on the back for now, and then we'll come back. Here's our equation that they give us to practice with. If we use elimination, to eliminate something is to get rid of it, right? If we want to eliminate, we want to get rid of. So what we can do is pick one of these to get rid of. In this case, and you'll see why in just a moment, I want to get rid of the y, because I can just add these together. If I add these together, x plus x is 2x's. Y plus negative y, see, I'm adding these 2 equations together. Y plus negative y is 0. There's no y's. The y's go away. Those cancel each other out. And then 9 plus 3 is 12. Now I have a very nice, easy equation to solve. 2x equals 12. Divide by 2. X equals 6. Great. What's y? Well, we can find out y by either one of these, because on this one, it would be 6 plus y equals 9, because we know x is 6, or 6 minus y equals 3. We can use either equation, right? So if I use that equation, 6 plus y equals 9, so what's y? 6 plus y equals 9. We just subtract 6 from both sides, right? Subtract 6 from both sides, you get y equals 3. On this one, 6 minus y equals 3. What is y? Again, y equals 3. It should equal the same because it's the same y. That's why I can pick either equation because either one will give me the same answer. So to solve this system of equations, x equals 6, y equals 3. This is the solution for these 2 equations. Just put a 6 in for the x's, put a 3 in for the y's, and it all works. Everything's equal to what it needs to be equal to. It's like, okay, well, that's not too bad. Go back and see what they did. First, they said, identify and create opposite coefficients. So that's why I chose the y, because I had a plus y and a minus y. So I knew if I add those together, it'll be 0. Y minus y. It says add the equations. That's what we did. We put a line underneath them and I added them. X plus x is 2x. Y minus y is 0 y's. And 9 plus 3 is 12. So I got 2x equals 12. Then I just solve it. 2x equals 12, divide by 2, x equals 6. Then I can substitute that into either equation. Either I can do 6 plus y equals 9, or I can do 6 minus y equals 3. But either way, I should get that final y equals 3 answer. And then we can check it, which we did. I put it in there, and 6 plus 3 is 9, right? Because when we found that, 6 plus 3 and 6 minus 3 is 3. That all works. 6 plus 3 is 9. 6 minus 3 is 3. So that checks out. That works on either way. And then if we graphed it, we should do that while we're here. If you want to do graphing in this class, you can use Desmos.com. DESMOS. If you haven't used Desmos before, that's what we're going to use for graphing in here. And open the graphing calculator. So this is the Desmos graphing calculator. So this is what the screen will look like. And you can log in and you can save equations if you're logged in, but I'm not logged in at the moment. But to put the equations in here, the first equation we had was x plus y equals 9. So let's put x plus y equals 9. Okay, so this is the graph of that first equation, x plus y equals 9. I can click here and add all the equations I want. The second equation was x minus y equals 3. That's the blue one. That's a positive slope. The red one's a negative slope. But look at this point right here. What is that point? That was our answer. We said x is 6 and y is 3. That's the point, 6 comma 3. The x is 6, the y is 3. So to solve a systems equation graphically, by graphing it, we just look to see which point exists on both graphs. That point exists on the red graph. That point exists on the blue graph. That's a part of both graphs. Zoom in there on it. So since that is a point on both graphs, that's the solution. Desmos.com. So, all right, let's go back. I show the same little graph right there. Doesn't get a whole lot bigger. Oh, this is the words that describe it. All right, learn more on systems of equations. Well, let's look at another example. Solve. Oh, this is a good one. Okay, we're gonna try this one. Okay, so I've got this written down in our notes now. X plus 2y equals 5. 5x minus y equals 3. And we want to solve this one. Now, looking at it right off, I want to do the same thing here. I'm still doing elimination. But when I add these together, nothing's going to go away. Because I've got a 5 plus a 5x. I mean, I got an x plus a 5x. That's going to be 6 x's. I've got 2y minus 1y. I'm still going to have a y. So I need to modify some changes. So let me ask you this. If I have 6 equals 6, we can agree that that is true, right? 6 does equal 6 every time. What if I multiply everything times 3? 6 times 3 is 18 equals 6 times 3 is 18. Is that still true? Yeah. If I multiply it by -2, so now I got -12 equals -12, still equal. Yep. So if I have some equation that equals something on the other side, and it does equal it, as long as I multiply everything by the same number, it's still going to be a true statement. So if I look at this and I say, what if I go down here and I multiply this by 2? So now I'm changing. My top one stays the same, x plus 2y equals 5. But this, when I multiply everything by 2, 2 times 5x is 10x. 2 times negative y is negative 2y. And 2 times 3 is 6. So if 5x minus y equals 3, then 10x minus 2y should equal 6, because I multiplied both sides times 3. And as long as I multiply both sides by the same number, it's still true. If it was true here, it's still true here, and it's still true here. So that's what I've done. I've multiplied everything by 2. And I did that because now when I have 2y and negative 2y and add those together, that's 0. 2y plus a negative 2y. Here I've got 10x plus x, that's 11x. Over here I've got 5 plus 6, that's 11. Divide both sides by 11. X equals 1. Great, x equals 1. So what does y equal? Well, let's see. Let's pick either one. Doesn't matter which one we want. Let's take the bottom one. 5 times x. We know what x equals. Minus y equals 3. So 5 times 1 is 5. Minus y equals 3. I need to subtract 5 because I want the y by itself. Negative y equals negative 2. So that's not what y equals. That's what negative y equals. Divide by negative 1. Y equals 2. So for this one, x equals 1, y equals 2. That's the solution. X equals 1, y equals 2. And I wrote it like a point on purpose because if we graph this, let's take a look at the graph of this one. X plus 2y equals 5. Go back to Desmos. Delete those. X minus 2y equals 5. There's the graph of that. And the other equation was 5x minus y equals 3. Did I do that right? 5x minus y equals 3. Oh, this is supposed to be plus. X plus 2y. It wasn't a minus. X plus 2y equals 5. Make sure I get that right. X plus 2y, 5x minus y. Here is the graph. Let's see what this point is. It's the point 1, 2. X equals 1, y equals 2. See, we found it algebraically, and then we proved it graphically. That, yep, that is actually the solution. All right, is that making sense? See what we did? Do you understand why we multiply this one by 2? I didn't have to multiply this 2. I could have multiplied this one by negative 5. I could have made negative 5x and positive 5x. You can pick whichever one looks simplest to you. Because if I would have taken this exact same problem, so let's take the same problem. Minus y equals 3. That's the same problem I had up here. But say this time, maybe I want to get rid of the x's instead of the y's, because I could. So let me take the top one and multiply everything times negative 5. So this one now changes to become negative 5x, negative 5 times 2y, minus 10y, negative 5 times 5 equals negative 25. So I changed the top equation. The bottom one stays the same. 5x minus y equals 3. Now when I add these together, this goes away. There's 0 x's left because negative 5 and positive 5. Negative 10y minus another y. I've got negative 11y. And here I've got negative 25 plus 3. So negative 22. If I divide both sides by negative 11, Negative 11 times negative 11, this is just y. Negative 22 divided by negative 11 is a positive 2. Negative divided by a negative. So y equals 2. Well, that's what I came up with up here. Y equals 2. Good. I'm glad I came up with the answer. Now y equals 2. I can pick either one of the original equations. So let's just do this one. Oh, we'll do that. We did this one last time, didn't we? Let's do the top one. X plus 2y equals 5. So x plus 2, what is y? Y is 2. So 2y is 2 times 2 equals 5. So x plus 4 equals 5. Subtract 4, x equals 1. Look, we got the same answer. 1, 2. X is 1 way. So it didn't matter whether I want to get rid of the y's and I do it this way, or I want to get rid of the x's and I do it this way. Either way, you should come up with the same answer. Either way. So that's an important thing to remember about it, that it doesn't matter which one you choose. It's just whichever one you like better when you look at it. Okay, let's go to page 3. So real world application. Oh, see, did they ever solve her problem yet? Missiles? Nope. Okay, we haven't solved her how many missiles and ray guns she needs. Let's look at a real world application here. You've been working the box office at a movie theater for a year and you're anxious to get a promotion. Promote me, boss. So your supervisor asked you to find out how many adults and how many children came to the recent screening of Amazing Algebra 2. Oh, I missed that one. I saw Amazing Algebra. I didn't know there was a sequel. I'm excited now. I'm a big movie guy. Amazing Algebra 2. The total number of adult and child tickets was 150. So we sold 150 tickets to that movie opening night, right? Packed theaters. So we know there was 150 tickets sold. We just don't know how many were adult and how many kids. We know that we charged $9 for every adult and we charged $6 for each child. And we know we made $1,155. We sold 150 tickets. We made $1,155. But I don't know. All right, Camden. I don't know how many were adult, how many were children. So it looks like we're going to need some algebra to solve this. So start by identifying the variables and writing the first equation. So we're going to count the number of adult tickets and the number of child tickets. We're going to use A for adult tickets and use C for child tickets. And we sold 150. So knowing that, what is our first equation going to look like? We know we sold 150 tickets, and we're going to call adult tickets A, child tickets C. What would our first equation be? Put something in the chat. Or you can raise your hand and tell me what you think it will be. We're going to write a systems equation, try to solve this and figure out how many adult tickets were sold, how many child tickets were sold. But right now we're going off, we sold 150 tickets. That's going to be used in our first equation. Give it a thought. This is the class participation section of our class time today. We're counting the number of adult tickets and child tickets, and we sold 150. A divided by C. What are you doing with the 150 though? If you're writing an equation, here's a hint, because a lot of times we use the word equation and we don't even think what that means. If we say an equation, that means there's an equal sign in it. If there's no equal sign, it's not an equation. It's an expression. It's an expression. But to be an equation, it has to have an equals. Diella says 9A plus 6C equals 1155. You're working on the second one already, Diella. You're on top of it. That's good. Edison's got a good one. Saharaza. All right. I know you don't go by your full name. What's your nickname there?
Saha.
Saha. All right. That's easier to flow off the tongues. Thank you. Saha. She's got AC equals 150. So let's put that in. A plus C equals 150. All right, let's submit that. Awesome. Yeah, that would be our first equation. The adults and childs added together is 150. I don't know how many of each, but I know there's 150 total. All right. So the second equation is the adult ticket costs $9. So the total earned from adult tickets is 9 times A, 9 times however many adult tickets are sold. Child tickets are $6. So that's 6 times C and earned $11.55. Now, Diella is already on top of this and she's got it. So if we say 9A plus 6C, and we know we brought in 11.55, that should be our second equation. 9A plus 6C equals 11.55. Awesome. Awesome. Okay, so then we have to identify and create opposites. So we can choose either to get rid of the A or to get rid of the C. So let's get rid of the C. And this is all here in Buzz. You can go through this on your own anytime you need to. So to get rid of C, we would multiply the first equation by -6 because we've got a plus 6C. We need a -6C. So the first equation changes to become -6A minus 6C equals -900 because we multiplied it by a -6. And the second equation stays the same. If we were getting rid of the A, we would just do the opposite. We'd multiply by -9 because we have a positive 9A. So you can do either way. Then we're going to add this together. The -6A minus 6C, -900. When we add those together, right here, we got 3A because -6 plus 9 is 3. The C's went away, which is what we were trying to do. And -900 plus 11.55 is 255. So we've got 3A equals 255. We're almost there. If we'd have done the other way, like I said, you can do the C's. And -3C equals -195. You divide by a negative, so it'll turn positive. But if we have this equation that's 3A equals 255, we just have to divide by 3 and we figure out there were 85 adult tickets sold. That's what we found out. And to figure out how many child tickets were left, we can just use A plus C equals 150. And since we know there was 85 adult tickets, the rest are child tickets. So we subtract the 85 and there were 65 child tickets. Isn't that great? Amazing Algebra had more adults seeing it than kids. The adults love the algebra. So there. So you tell your supervisor there were 85 adult tickets sold and 65 child tickets. And she's so impressed you got the promotion. Nice work. Good job. And here's, if you want more examples, I don't go through every example or we run out of time. Here's another example that you can try on your own. Here's what I like about our lessons. You can try this on your own. If you're like, I need more practice. So you do this. 3 bags of candy, 2 boxes of cupcakes cost $7. 4 bags of candy, 5 boxes of cupcakes cost $14. Find the cost of 1 bag of each. You can work that on paper, and then they give you the answers to check yourself here. So, you can check and see if you get the right answer because they'll give you the answers in the lesson. So I'm not going to work that one because you can check your work yourself. You can try that one and then see how it works out. But let's get back here. I think we're about to do the, sometimes they disappear. Let's look at this. Here's a good ant. Let's talk about this real quick. I'll work it very slowly, but put this on your notes. 2x plus y equals 3 and 4x plus 2y equals 6. And see what you can do by eliminating something there and start working to see where you get. I'm going to work it, but I'm going to be behind you instead of in front of you this time. So write that on your paper. 2x plus y equals 3. 4x plus 2y equals 6. Then you got to pick which one you want to eliminate. Do you want to get rid of the x's or do you want to get rid of the y's? And again, you can do it either way. There's not a wrong choice there. It's just whichever one looks easier to you. I'm going to say I'm going to get rid of the x. That just looks easy to me. because I've got a 2x and a 4x. So I know if I make this a negative 4x, right? So if I multiply everything by negative 2, it's not a good 2. Multiply everything by negative 2. That becomes negative 4x. And then I've got 4x down here plus 2y equals 6. I'm not doing anything to the second equation. So then I take negative 2 times y. I've got negative 2y. I got negative 2 times 3, negative 6. Now I'm ready to add them together and my x will go away, right? So I've got 0x. And then I've got negative 2y plus 2y. I've got 0y. And I've got negative 6 equals 6. I got 0 equals 0. Is that what you got? Keep working if you're still working on it. What does x and y equal? I'm supposed to come up with an answer. But I ended up with 0 equals 0. Something's going on. Oh, Joseph got 0, 3. You got something different here. 2x plus y equals 3, and then 4x plus 2y equals 6. You got to make something the same. I made the x's the same, with one of them negative, one of them positive, so they canceled out. But my y's ended up canceling out, and my number ended up canceling out. I got 0 equals 0.
Usually I'd ask if you did something wrong, but you're the teacher.
Well, that's a good point to make there, because I make mistakes sometimes too. And if you do see something wrong, say, hey, Mr. Brock, you forgot a negative, or hey, that isn't added correctly. Point it out, because I don't want everyone else in the class sitting there going, well, that doesn't look right, but that must be it because he's the teacher. Because yes, I do make mistakes. And I love it when you catch them before I do. If we were in a class, I need to find a way to do this virtually, because when I used to teach in a class, if you found a mistake before I found the mistake, I had star stickers that I would hand out. And so students would compete to get the most stars. And I would have a sheet of stickers, and I would try to go the whole year without giving them all out. See, because I didn't want to make a lot of mistakes. So I need to find a way to do that, to issue virtual stars or something, so you can collect them. But we can check it by graphing, right? Remember, if we graph it wherever the point meets each other, that should be the answer. So it's like, I don't have an answer for x and y. My x and y went away. So let's graph this and see what it comes up with. Because, like this was the answer on this one, 1, 2. So if we graph these two equations, 2x plus y equals 3. So there's the graph of one of them. There it is. It's a black one. Now let's graph the other one. 4x plus 2y equals 6. Oh, well, there's the red graph. Let's zoom in there. There's the red graph. If I turn it off, there's the black graph. Here's the deal. These are exactly the same equation. Look, they make the exact same graph. It's the same line. Every point that's on the red graph is also on the black graph. So that's why we got 0 equals 0. There are infinite solutions. Infinite solutions, because 0 always equals 0. You get the same number. This is a true statement. 0 does equal 0. So there are an infinite number of solutions. And if we want to know what some of those solutions are, we go back here and we say, okay, that's a solution, 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 that's a solution. Negative 4, 11, that's a solution. But yeah, 0, 3, that's a solution. 1.5, 0, that's a solution. This is a solution. All of these are, so there's an infinite number of solutions, because every one of these points that's on one line is also on the other line. So that's why this looked weird, that we didn't end up with any x's or y's, and it just ended up 0 equals 0. So let's look at another possibility of something that may go odd. So let's see. Yeah, they got 0 equals 0 when they were doing that as well. And they said, oh, it's the same line. It's the same line. All right, close that. Here's a second example. Okay, I like this one too. This is good. So if we solve, so try this one, x plus y equals -1. And 3x plus 3y equals 6. Okay, I don't think you're going to get a 0 equals 0 on this one. All right, this one will be different. X plus y equals -1. 3x plus 3y equals 6. Again, you can get rid of the x or you can get rid of the y. Your choice. I'm going to get rid of the y this time just to do it differently.
Oh, yeah!
Which means if I've got 3y and just 1y, I need to multiply this up one by -3. Because that'll make opposites. So -3 times x, -3 times plus 1y. So now I've got negative. And -3 times -1 is a +3, right? Negative times a negative. So I've changed that top one now. So now I can put the bottom one. All right, take it from there. You didn't get 0 equals 0 this time, right? Add those together. Add. Well, did you figure out what x and y equals? Some puzzled faces. Like, no, I haven't figured out what x and y equals. Well, let's see. -3x plus 3x. Oh, we've got 0 x's again. -3y plus 3y. So this side just equals 0 because everything went away. 3 plus 6 is 9. 0 equals 9. Well, I said you wouldn't get 0, 0. Joseph, how'd you get 2, 0, 0, -2? Did you graph that or something, or how'd you figure that out?
Desmos.
Desmos. Well, let's see. So remember on Desmos, because yeah, I got 0 equals 9, which does 0 equal 9? No, that means I got something that's not true. Remember, like if it was a minus, and these are two different equations, the solution would be wherever the two graphs cross each other. So like Joseph, you have two different answers. You got x being 2 and x being 0, and then y being 0 and y being 2. We can't have different x's and y's. There has to be one point, like 1.50 on this one is on both of these equations. We could substitute 1.5 in for the x and 0 in for the y, and both of these would be true. We don't have a solution there and another solution up here because up here is only on the red graph. It's not on the black graph. So the solution is the point that exists on both of them. So let's look at this one that we just got 0 equals 9 and see what's going on with that. We had x plus y equals -1. All right, so there was one of the graphs we had right there. The other graph was 3x plus 3y equaled a +6. So where do they touch? Where's that point that's on both lines? Yeah, they don't. Never. They're parallel to each other. They're parallel to each other. There's not a point that they both have. So when we get something like this, which is not true, right? Not true. There is no solution. This is true. This is true. So there's infinite solutions. When it's not true, there's no solutions. That's the difference. If we don't get an X and a Y, right? If we don't get an X and a Y, then we'll either get a statement that's true or a statement that's not true. So if it's true, there's an infinite number of solutions. If it's not true, there's not any solutions. There's never a point where 0 equals 9, but 0 always equals 0. So let's see if we haven't know enough now to figure out how many missiles and ray guns that she can use to maximize the number of weapons she can have, because she can have 7, and to try to use all of her batteries at the same time. I think we can do this now. We have an M and a 5M and an R and a 3R. So do we want to get rid of the M or get rid of the R? Like we've seen multiple times, we can do either one. So just give me one. First one to put it in the chat, we're going to get rid of the M.
R.
Oh, give me, Keith. Which one?
R.
R. We're going to get rid of R. Okay, so how do we get rid of R? We're going to multiply this by something. What are we multiplying this by? Anybody? Oh, you're already confused? Come on, I know a lot of you know it. What am I multiplying the top equation by if I want to get rid of R? Boy, the chat is like silent.
Could we divide R by R?
No, we're going to add these together after we change this first one. Right? Because like over here, we wanted to get rid of the Y. So we multiplied by 2 so that we had 2Y and negative 2Y. So they went away. Up here, we had a positive Y and a negative Y. So when we add those together, they went away. Here we got rid of the X's. We had a 5X and an X. So we multiplied by negative 5 to give us a negative 5X and a positive 5X. Because we need the same number, but one of them is a negative, one's a positive. So when we add them together, they go away and they're 0. So if we want the R to go away and we've got a positive 3R, yep, Saha's got it there. We need a negative 3R up here. So let's multiply everything by negative 3. So this one now becomes the new equation, negative 3M minus 3R, negative 3 times 7, we got to do both sides, negative 21. We didn't change the second one, so I'm going to add them together down here. So we took that one and we changed it. We multiplied it times negative 3. Because we wanted to get rid of the R. To get rid of the R, we've got to have a positive and a negative number exactly the same. So we're going to add those together. All right, so adding these together, we've got a positive 5M and a negative 3M. So that means we have 2 M's. 3R and a negative 3R, that's 0. No R's. And we got 23 plus a negative 21. That just leaves a 2 then. So we've got 2M equals 2. Divide both sides by 2. So she should have 1 missile. So using this first equation, or the second one if you want to, but the first one's a lot easier. 1 plus R equals 7. R equals 6. So she should have 1 missile and 6 ray guns, and that will use up all 7 spots and hopefully use all her batteries. Let's see. 5 times 1 missile plus 3 times 6 ray guns. Will that use all 23 batteries? 5 times 1 is 5. 3 times 6 is 18. 5 plus 18. Perfect. This is the solution because it works. 1 plus 6 is 7, and 5m plus 3r is 23 because we tested it right there. So this will be the maximum firepower she can use to use all of her batteries and use all 7 weapons. See what they did here. So, explanation. This is the like 0 equals 9. And they're parallel lines. So it talks about that in our lesson, the parallel lines and the exact same line, infinite solutions. Let's go to page 5. I think page 5 is where they solve her missile one here. Oh, no, we're talking about literal equations. Literal equations. Because we're going to talk about solving by substitution next. So this was all by elimination. We're going to talk about substitution. So let's talk about this real quick. So if we have this equation, 3x plus 3y equals 9, and I want to know what would it be if I just said, what is x equal? What is x equal? If I want to solve this for x, the way you solve any equation for x is to anything that's not an x, get it to the other side. This is not an x. If we subtract 3y from both sides, remember we can, as long as we do it to both sides, it's legal. We have 3x equals negative 3y plus 9. Right? Because when we subtract 3y over here, there wasn't any y's. So that's just a negative 3y. And we still have a 9. 3x equals this. I don't have x yet. I've got 3 times x. So if I divide, I got to divide everything. X equals negative 3y divided by 3 is just negative y. And 9 divided by 3 is 3. So this is what x equals in this equation. X equals. That's how we figure that out. Ooh, that's kind of dirty when I try to do it on pencil. X equals. So we're going to do a few on here. If x plus y equals 1, what does x equal? And you do the same thing that I just did on paper here. You move everything to the other side and get x by itself. X equals. I want it to be x equals when I'm finished. So if x plus y equals 1, and there's really more than one way you can write that, but usually we write the variables first. What is x equals? I wonder if they want us to put the x equal in there, like x equals, we'll try it that way. This is probably the easiest one they're going to give us on the page. Here. If x plus y equals 1, this is not an x, so I'm going to move it to the other side. X equals, I've got my final answer, negative y plus 1. You can write it 1 minus y. That's the same thing. But generally, as a rule, we put the variable first and then anything that's not a variable after it. So this is the more acceptable way to write it there. But this means the same thing. You got a positive 1 and a negative y. But this is the way we generally would write that because we like variables before numbers that don't have variables. So negative y plus 1, that's what it is. Negative y plus 1. What about this one? X plus 7y equals negative 4. X equals what? That one's not any harder than the one above it. It's just one step. You just have to move the y to the other side. Which means you have to subtract 7y from both sides. Minus 7y. And you still have a minus 4. You just move this to the other side by subtracting 7y. X equals negative 7y minus 4. I don't know if it's going to take that. Yeah, it doesn't like it. Maybe because it's not spaced out. Maybe it wants 1 minus y. But we're gonna run out of time if I don't work through this. So we're going to use substitution now to solve the systems of equations. 5x plus y equals 9 and 4x. I'm going to work this on paper first, and then we may or may not watch it. They solve it with a video right here. We have a video. So I like to do this in person. 2 minutes and 48 seconds. we're going to work this as a class, and you can watch this video. If you want to go back and review this, you're like, okay, that confused me. Go back and watch the video, but we won't take class time to watch this video. There's more videos. We may watch one of them, but I want to write this down and talk our way through it. So let's say we want to solve this, and we're going to do this by substitution. Substitution. Okay. Substitution. We could, if we did it by elimination, we'd multiply this by -3, right? So we'd have a -3y and a +3y, because that would work okay for this. Sometimes it wouldn't work too well. And we'll look at a case where it wouldn't work well, so we want to do so. But this one's a nice one for substitution as well. Because if we look at this, we want to get one of these equations to be x equals or y equals, like we were doing up here. Y equals or x equals. And if we take this first equation, 5x plus y equals 9, we can get y equals real easy. Let's just move the x to the other side. So we've got y equals -5x plus 9. And you're like, Mr. Brock, why don't you just do 9 minus 5x? You can. That's the same thing. But traditionally in math, we like to put variables before numbers. Variables before numbers. This is the same thing, though. If you want to work with 9 minus 5x, just don't confuse yourself. The main thing is make sure you keep the negative with the x wherever it is. See, -5 is in the front. -5 back here. The 9 is a positive either way. But this is what y equals. All right, so since this is what y equals, so there's our y, right? We can go into this equation, the other equation. Since we used this equation, we have to now choose the other one. So let's go into the other equation. 4x plus 3 negative 5x plus 9 equals 16. See what happened. This is exactly the same equation as this, except I took the y out and substituted what the y is equal to. This is what y is equal to in this equation. Because on this equation, this is exactly the same. We just rearranged it. We didn't change it. We rearranged it. It's still the same equation. If we graph this and we graph this, it's still the exact same line. Here, let's prove that to ourselves. That's a good thing to do. Let's do that. Let's prove to ourselves that is the exact same line. So the first equation was 5x plus y equals 9. Okay, that is the line. I'm going to turn that line off. I still got it there. The other equation we said was y equals -5x plus 9. All right, let me turn the first one back on. Turn the second one off. Oh, look there. Same line. Blue, green, same line. So just because I rearranged it didn't change it. It's still the exact same equation. Nothing changed. I just rearranged it. So since y equals that, I can now take that and substitute it into the other equation. And now look at the other equation. There's only x's. We can solve for x because there's no y's now. The y is gone. So let's get rid of the parentheses. So 4x is still here. We have to distribute the 3. So 3 times -5x is -15x. And 3 times 9 is 27. And it still equals 16. We have like terms. We can combine these. 4x minus 15x is -11x plus 27 equals 16. Still trying to solve for x. Subtract 27 from both sides. -11x equals 16 minus 27. Divide by -11. X equals 1. By substitution, we figured out x equals 1. We got rid of the y. Now we need to go back. 5 times 1 plus y equals 9. Substitute this 1 back into either one of these equations to figure out what y is. I just chose the first one that looked simpler. It looked easier. 5 times 1 is 5. Subtract 5 from both sides. Y equals 4. So the answer is 1, 4. X is 1, y is 4. Substitution. Let's check it on graphing. 5x plus 5. There's the first equation. We already had it there. 5x plus y is 9 is the first one. The second equation was 4x plus 3y equals, and it was 16. Okay, there's the two equations. I want to make one of those red. I don't like them to be close to the same color. So if we zoom in here and see what that point is, 1, 4, which is exactly what we came up with. We said 1, 4 is the answer. That is the point that exists on both graphs. The point that works for both equations. When you substitute 1 and substitute 4, it'll equal 16. When you substitute 1 and substitute 4 up there, it'll equal 9. So substitution works like this. All right, let's go back and so they have a video, 2 minutes, 48 seconds, if you want to see how they do it. And she'll do it pretty much the exact same way I did, but just showing you that in a different voice. Let's watch the video on this one. This one, if you look at it, this is one that would not be good. I want to write it down just to show you one thing. I'm not going to solve it. I just want to show you why substitution might be the better method. Okay, if I write this down, I'm going to solve it. And I say, I don't like this substitution mess. That's a mess. I'm going to do elimination, which means I want to add these together and make something go away. You going to get rid of the x or the y? Well, wait a minute. I've got a 2 and a 3. There's not a number I can multiply this by to make a -3. There's not a number I can multiply this by to make a -2. I've got a -5 and a +4. That's great, but what am I going to do? Multiply this one by 1.25 to make it a +5? These don't eliminate real easily. See, these were a lot better in the fact that this was already just a 1 and a -1. This was able to multiply by a -2 and make a 2, a -4 and a +4, the same numbers. This doesn't have a nice number I can multiply by. I would have to multiply both equations to get something in common. So this is a lot more work for elimination now. So maybe substitution is a better method on something like this where you don't see a good way to eliminate. So that's what they're showing us. So we're going to watch this. All right, here we go. Okay, there's no audio. It says down here. I'm like, why am I not hearing anything? All right, let me pause this and we'll talk through it. Pick and solve. So this time, let's isolate the x in the first equation. So we chose the first equation, the 2x plus 4y equals 16. And we're like, okay, we think we can get it to x equals. So the first thing we do is move the y to the other side. We don't need the y with the x. So when we subtract 4y, we get 2x equals -4y plus 16. Okay, let me hit play again. We don't have x yet. We got 2x. So we're going to divide everything by 2. Right? And we have to divide everything by 2. So when we divide 2x, we get x. When we divide -4y plus 16, we get -2y plus 8. So now we're going to take that x equals -2y plus 8. And we're going to substitute it in for x in the other equation. Let me back it up. They're going a little faster than what we're talking about. The other equation is 3x minus 5y equals negative 31. So instead of x, we're going to substitute this negative 2y plus 8 in for that. See, that's this equation and this equation are the same. The only thing that's happened is since x equals negative 2y plus 8, we want to take out the x and put in the negative 2y plus 8. Okay, so now we can solve this for y because there are no x's in this equation. Get rid of the parentheses first, distribute the 3. So when we distribute the 3, 3 times negative 2y is negative 6y, 3 times 8 is 24. The rest of the equation hasn't changed yet. Then we're going to combine the like terms. See, the negative 6y and the negative 5y are like terms. And the 24 stays the same. And the 31, negative 31. Now we're going to move the 24 to the other side. And we get negative 11y equals negative 55. Solve for y, divide by negative 11, and we get y equals 5. Now, since we know y, we can go back and substitute into one of the original equations. We could pick either one. So they're going to do both of them. So if we chose the first equation and substitute the 5, we got 2x plus 20 equals 16. Or we could have done it in the second equation, 3x minus 25 equals negative 31. They're just showing you that it doesn't matter which equation you pick. Solve for x now. And either way, we'll get x equals negative 2. So the solution is negative 2, and then y is 5. Negative 2, 5. Check out the other 3 ways it could have been solved by isolating a different variable in step 1. Yeah, that's the thing. If we have these two equations, we can do x equals with this equation, or we could do y equals, or we could do x equals from this equation, or we could do y equals. And they show you all the ways. The video did the first one. It made x with the first one. But we could have done y in the first equation. Now, we'd ended up with a fraction. Y equals negative 1/2 x plus 4. But that would work. You just end up dealing with some fractions. Eventually, it goes away, and you get x equals negative 2. Or we could have taken the second equation, 3x minus 5y equals negative 31. And we got a lot of fractions to deal with there. 5/3 y minus 31/3. But again, when you start solving them in the other equation, you end up with y equals negative 5. Or we could have done y and had 3x to the 5th plus 31/5. So that's why sometimes you'll end up with fractions on all of them, and maybe you want to do elimination. It's like, I don't want to deal with all these fractions. I'll do elimination instead. That's fine. Maybe you end up with some fractions when you're eliminating, or a lot of work to eliminate. Sometimes it's easier to substitute. So why solving for x in the first equation is the simplest one to do, the one they did in the video, because it's the only one that we didn't have to deal with fraction answers. It had a coefficient of 2, and everything was divisible by 2. So fractions were not an issue. So that's why they chose that one. Here's another example on substitution. So you can go through another one, like to give you more options. Gives you these two equations. So you can try these two equations and see if you can work that by substitution. That's a real easy one because you just have an x. So it's real easy to get x equals. Real easy to get x equals and substitute that into the other one. So let's go back to Danielle and her rocket problem. So yes, I'm going to write that one down. Which you think would work best on this? You think this would be easier to do substitution or elimination? Well, looking at it myself, either way would be pretty simple because we'd be real easy to get m equals or r equals and substitute. Or we can multiply by -5 or -3 and eliminate real easy. But let's do substitution since this one looks like it's a real easy one for substitution as well. And again, either way would be a real easy. But we can take this first equation, m plus r equals 7. And let's move the r to the other side. So m equals -r plus 7. Substitution. Substitute that into the other equation. 5 times negative r plus 7 plus 3r equals 23. See, we just substituted it in what m equaled. So now get rid of the parentheses, negative 5r plus 35. We just took the 5 and distributed it in. Plus 3r equals 23. We can combine like terms. Negative 5r plus 3, because they're on the same side of the equal sign, so we just combine them. Negative 2r plus 35 equals 23. Subtract 35. Negative 2r equals 23 minus 35 is negative 12. Divide by negative 2. R equals 6. M plus R, M plus 6 equals 7. So she should use 1 missile and 6 ray guns. 1 missile, 6 ray guns. Because that will give all 7 slots. That'll fill up all of her weapon slots. And the missile will use 5 batteries. Each of the ray guns, all 6 of the ray guns will use 3 batteries each. 5 batteries plus 3 times 6, 18 batteries. That will use, oh, not 25. That will use all of her batteries. All 23 batteries are taken. And all 7 weapon slots are taken. So that's how we solve with substitution. You can go back and say, can I do that by elimination? You bet. Go work that by elimination and see if you get the same answers. Because you should. If you don't, you missed a step somewhere. But elimination, they show you how to do it. So you can go back and check yourself. Substitution, they show you how to do it. I want to show you this. We're going to run out of time here. 3 variables. If you have 3 variables, and we're not going to work one because you don't have to work one in the assignment this week either, but let's look at it real quick. If you have a system with 3 variables, one way to do this is by elimination. But here's how it works. You have to pick 2 equations and narrow them down to make just 1 equation. And then, let me kind of write that. We kind of write that down just to emphasize this a little better. Okay, this is what they're going to tell you in the lesson. They say if you have 3 variables, x, y, and z, then you need 3 equations. And so the way you would solve this, like take these first 2. Now look, if we add these together, look, the y is going to go away. 2y and negative 2y. So we would add those together, x plus 2x to be 3x. The y is gone. And we have negative z plus z, so that leaves just 1z, and it equals 5. So we took these 2 and we simplified it and got rid of the y. Right? So that makes that a little simpler. Then we would take these 2 next, and we'd try to do the same thing, get rid of the y. So this one we'd have to multiply by 2, a negative 2. See, we got a negative 2y and a negative y. So if we multiply that one by negative 2, then we've got negative 4x plus 2y, negative 6z equals negative 18. So we've gotten rid of this one. So using these 2, we would put those together now, and we'd have negative 2x. The y's go away. Negative 4z. 8 plus negative 18, negative 10. Now we would solve this the same way we've been doing everything else. We've got it down to 2 variables and 2 equations. So we would solve however we want, elimination or substitution, or however we need to do that. But that's the way you do it. If you have 3, you have to cut it down, cut one of the variables out by doing the first 2 equations and getting rid of one of the variables, and then do the second 2 equations and get rid of the same variable. So now I've got it down to I can solve, because we can't really solve 3 at a time. We need to eliminate it down to 2 at a time. And that's what they're going to show you in here. See, 3x plus z equals 5. That's the first 2 equations. And then they go through the second 2 equations and get that down to, what did they eliminate there? Oh, they're just showing the steps to 5x plus 5 equals 15. They chose, they went the first and third equation. You can do that as an option. Instead of doing, the only thing about the second time is you have to use the equation you did not use the first time. We did not use this one the first time. But they used this one and this one to come up with the second equation, which that's fine. You can use either one of these, but you have to use the third one. So they did it a little bit differently than I did, but you'll still end up with the same answer. So that's interesting. And then you just solve the new system where you only have x's and z's. All right. And here's doing one with substitution. And again, you can do the same thing. You just have to eliminate it down to where you just have 2 variables and 2 equations. Okay, and here's the lesson summary, which means this is the end of our lesson. The lesson summary is right here. And it goes through, here's the steps. If you want to write down the steps, or if you have a printer, you can print this, and this can be your notes for this lesson. Because if you have a printer and you want to just keep this in a notebook, here are the steps to solve by elimination. And here's those special cases. If you get something that's true, there's infinite solutions. If you get something that's false, there's no solution, because parallel lines are the same line. Here are these steps. Like, again, if you want this in your notes or print this out, here's the steps for substitution. And again, same thing, true, infinite, same line. And here's how to do 3 variables. You gotta eliminate it down to get rid of a variable, but the steps for that, and by elimination or substitution. So they show you both. And then they talk about the graph. That is the lesson summary. The next several pages, I just want to point this out, are practice problems. If you're confused, even if you're not confused, you should come do some practice problems. This says solve each system and then match the answer. So here's 5 problems right here. You can do them by elimination. You can do them by substitution. You can do them by graphing, however you want to do them. But if you select this and select the correct answer, it'll go away. Like there. Nope. It says that's not the right answer. So if you select this one and get the wrong answer, try again. That means you messed something up. But if you're having trouble and can't get any of it, it shows you how to do it right here. Here's the solution. There's the solution for the first one. There's the solution for the second one. There's the solution for the third one. These practice problems all give you the answers and show you how to work it. Scroll down the page. If this is 3 variables, what's the answers? Step 1, step 2, step 3, step 4. It's got all the steps right here. It'll show you. Here's another one. Oh, and after you do this one, there's a second one, 1 of 2. There's 2 right here. There's 2 right here. There's 2 right here. Then page 8. What do you know? More practice problems, but they're a little different this time. Solve the systems of equations. So here just gives you this. You do it on paper. You come up with an answer. And then afterwards, check your work. Now, again, you might have solved it differently. You might have done substitution when they did elimination. You might have done elimination when they do elimination, but you eliminated the X instead of the Y. It doesn't matter as long as you get the same answer. If you don't get the same answer, then you might go back and see what they did. But the answer is fractions on this one. Page 9, more practice problems. They will give you practice problems. Use this to test your knowledge of solving by substitution. It says, try this by substitution. and see what answers you get. Is it -4, -5, or +4 and -5? Submit. There are 10 problems there. Look at the bottom, 1 of 10. So once you get that, say, oh, I think it's this one. Submit. Yes, that's right. Now I can go look at the second problem. Here's another one. Multiple choice. So that's a good place to practice and see if you know it. And then down here, here's 5 solutions. If you work this one, which solution is it? Well, I think it's this one. Nope. See, it won't let me drag it to that one. That's not the right answer. It's like, oh, this one doesn't have a solution. See, it'll stay if you choose the right answer. And then it gives you the next one. Which one of those is the answer for that? And then the last page just tells you to read the lesson, make sure you understand those questions, and do the equation, do the work. Here's the lesson. The assignment. Let's look at the assignment before I let you go. Solving systems of equation algebraically. You got 3 attempts. Look, so if you don't do well the first time, you got 3 attempts. Solve this. Just gives you system of equations. Solve it, multiple choice. Solve this one. And it doesn't tell you how. You can do it by elimination, substitution, or whatever you like. This one has a fraction answer. This one wants you to try the substitution method, which would be pretty easy. So see if you can do that by substitution and get one of these answers. Here's a word problem. How many guppies did she buy? You may have a different word problem. And then this one does the 3. I said you're not going to have to solve the 3. You don't have to solve it. You just have to set it up. Which set of equation matches this? They all chose to go to the movies. Some chose drama movies. Some chose comedies. Some chose documentaries. So X is dramas. Y is comedies, documentaries. So Gina chose 11 movies total. Right? So X plus Y plus Z equals 11. That's Gina's equation. Sam chose twice as many dramas, 3 times as many comedies, twice as many documentaries. Which one of those equations fits that? So you're just choosing the right answer. 5 questions, all multiple choice. That's it. We only have class on Thursday. So if you're struggling with this and want help, come Thursday, even if your grade's great, right? Because only under 70% has to be here. Has to be here. But otherwise, have a great day. And we will catch you guys next time, either Tuesday next week or Thursday this week.